Hi, good day everyone. Welcome to the new discussion of Mathematics 9. But anyway, how are you today? Are you all good? Okay, I know that all of you are set. So, before we introduce our topic for today, let's have first our objectives. So, our objectives for today, at the end of this lesson, you should be able to apply the theorems to show that the given triangles are similar. To begin with our discussion for today, our new topic for today is all about applying triangle similarity theorem. But what are those triangle similarity theorem? First is the AA similarity theorem or the angle-angle similarity theorem. Next is the SAS similarity theorem or the side-angle-side similarity theorem. Next is the SSS similarity theorem or the side-side-side similarity theorem. And the last one is the triangle proportionality theorem. So, to introduce those triangle similarity theorem, let's start with this. First one is the AA similarity theorem or the angle-angle similarity theorem, which means that there must be two corresponding angles congruent in each triangle in order to prove two triangles similar. Somehow, even easier to prove that two triangles even similar, the interest of simplicity will prefer to it as the AA similarity postulate. The postulate states that two triangles are similar if they have two corresponding angles that are congruent or equal to its measure. For you to be able to measure the given triangle of congruent angles in AA similarity theorem, example for the AA similarity theorem. So we have a triangle Q, P, and R, which means the given number is Q is 100 degree and the P we have 45 degree. So all you need to do is to find the measure of the third angle in each triangle. So we have to write the theorem for this triangle. So we have the triangle P, Q, and R. So then you need to write the sum of the theorem of this triangle. So we have an angle P plus an angle Q plus an angle R, then you write is equal to 180 degrees. Why 180? It's because every triangle is equal to 180 degrees. Then after do this is substitute the given angle measures. So we have the given angle measures, we have the M angle P is 45 degree plus the M angle Q we have 100 degree. Then you just need, since our M angle R is unknown, then you have to copy the M angle R, then is equal to 180 degree. So after substitute the given angle measures is, as you can see that the angle R is unknown, then you just need to simplify. So if you add 45 degree plus 100 degree is equal to 145 degree. Then plus the unknown angle R is equal to 180. Then you need to subtract 145 degree from both sides. So you just need to copy the 145 degree plus angle R minus 145 degree is equal to 180 degree minus 145 degree. Then after do this is to simplify. So now our unknown, which is angle R, is 35 degree. So now our angle R is 35 degree. Second example. So the second example is we have the T, S, and U. So the given number is T is 100 degree, and the other given number is U, which is 35 degree. So now same steps like what we have in example number 1. So first we have to write the triangle sum theorem for this triangle. So we have angle S plus angle T plus angle U, then is equal to 180 degree. Again, every triangle is equal to 180 degree. So we have the angle S plus the given number of angle T, which is 100 degrees, plus the angle U, which has a given number of 35 degree, then is equal to 180 degree. Then after to this is simplify. So we have to copy again the angle S plus the sum of the angle T and angle U, which is 135 degree, then is equal to 180 degree. Then after to this is subtract 135 degrees from both sides. So we have an angle S plus 135 degree minus 135 degree is equal to 180 degree minus 135 degree. Then simplify. So copy the N angle S, then minus the 180 degree into 135 degree. So we have 45 degree. So our unknown now, which is S, is 45. So now, did you know how to find the measure of the third angle in each triangle? So, therefore, three angles of triangle PQR are 45 degree, 100 degree, and 35 degree. Three angles of triangle STU are 45 degree, 100 degree, and 35 degree. Because two angles in one triangle are congruent to two triangles in the other triangle. So, the two triangles are similar. Next is the SAS similarity theorem, or the side angle side similarity theorem, which means if two sides of a triangle are proportional to two sides of a second triangle and their included angles are congruent, then the triangles are similar. By that means, to determine whether two triangles are comparable, it is not essential to examine all angles and sides. In fact, it serves to know that the triangles are related if you merely know that two pairs of sides are proportional and their included angles are congruent. For example, so we have the two triangles in SAS similarity theorem. So the first one is the which is A, B, and C. So we have a given value of the A and B, which is 12. And for the B and C is 24. And we have the given value of the angle B, which is 50 degree. And for the second triangle, we have which is D, E, and F. Which is the angle of F and D is 8, and for the E and F is 16, and for the angle F we have 50 degree. So we can say that the angle B is equal to angle F, and these are both included angles. So we can see that the angle B is equal to angle F, and these are both included angles. Then we can just have check that the sides around the angles are proportional. So we have the solution for this example. So we have A and B over D and F is equal to 12 over 8 is equal. So now, to get the final answer of this 12 over 8 is all you have to do is divided by both by 4. So we have 3 over 2. Then second is B over F E, which is the angle B and C is 24, and the angle F and E is 16. Then reduce this number, then the answer is 3 over 2. So, since the ratios are the same, triangle ABC and triangle DFE by the SAS similarity theorem. So, we have the second example for the SAS similarity theorem. So, we have which is E, G, F, which is the first triangle. And next we have the U, T, which is the second triangle, the U, G, and T. So we have the given value of E and V is 50, then UG is 60, then the EF is 121, and for the F and T is 35, and for the U and P is 66. So the angle GT now is unknown. So we can say that triangle EGF and triangle UGT by SSS theorem or SAS similarity theorem. So we have to write the solution. So the first one is you need to write the, which is G and T over U and T is equal to G F over E F. So the first steps here is write the observable proportion. So these are the observable proportion. Next is you just need to solve for the unknown. So you just substitute the given number and also the unknown. So we have G and GT over, which is the UT is, we have 66. Then is equal to G and T. Since the G and T is unknown, then you just copy the GT. Then plus the given number of the value of GF, which is 35. So we have the value of G and F. GF is 35 over the value of EF, which is 121. Then this is the second step, solve for the unknown. Then after this is you just need to solve the unknown. So we have the simplify the 121, copy the unknown GT, then is equal to 66. Then the quantity of the unknown GT plus the value of GF, which is 35. So after this is use the known values. So we have the known values, we have the 121, we have to reduce the 121. So 121 now is 11. Then you just need to copy the unknown, which is JT, then is equal to 6. Then copy the quantity of GP plus 35 for GS. So this will be now the known values. The next is solve for the unknown GT and simplify. So we have 11, which is unknown, copy the unknown GT, minus 6 JT is equal 6 quantity of 35. Then solve for the JT and simplify. We have the 11 minus 6 is equal to 5. And copy again the unknown, which is JT. Then you need to multiply the 6 times 35 is 210. Then our unknown JT now is 42. Then just copy the 42. So this will be now the unknown JT. I hope that you know how to solve the SAS similarity theorem. Next is the SSS similarity theorem, or the side-side-side similarity theorem, which means that if the length of the corresponding sides of two triangles are proportional, then the triangles are similar. So by the mean of that if all of the corresponding angles and sides of two triangles match up, they are said to be similar. To determine whether two triangles are similar, it is not necessary to examine all angles and sides. In fact, all you need to know to conclude that the triangles are comparable is that all of their sides are proportional. So, for you to be able to measure the SSS similarity theorem, I have here an example. So, we have which is A, B, and C, which is for the A and B is 21, for the B and C is 28, and for the CA or AC is 14. And the next triangle is which is D, E, and F. So we have the value of 10. For the ES is 15, and for the FP is 20. So first, we will need to find the ratios for the corresponding sides of the triangles and see if they are all the same. So, let's start with the longest sides and work down to the shortest sides. So, we have BC, which has longest sides of 28 over FD, which is again BC has the longest sides of 28, and the second here is FD, which has the longest sides of 20. Then all you have to do is to reduce this number. So to reduce this number, we have 7 over 5. Then next is the next for the longest sides. So we have B and A over FE. So why BA and FA? So here, as you can see, the B and A has the second longest sides, and for the other triangle, FA has a second longest side. So for the BA, we have 21, and for the FE, we have 15. Then same as this at the upper, which is to reduce this number. So, to reduce this number, we have 7 over 5. Then, next is the solve for the shortest sides. So, we have AC over ED. Why AC and ED? It's because AC has a value of 14, which is shortest side. Then ED also has a shortest side's value of 10. Then all you have to do again is to reduce this value. Then we have 7 over 5. So it seems that very simple. So since all the ratios are the same, triangle ABC and triangle DEF by means of the SSS similarity theorem. Did you guys get it? So, thank you. Okay, let's proceed to the next. Next, the last one is the triangle proportionality theorem, which means that if a line parallel to one side of a triangle intersects the other side of the triangle intersects the other two sides, then it divides the two sides proportionally. So it means to determine the triangle proportionality theorem, triangle proportionality theorem is divided into two sides congruent halves. So for you to be able to measure the triangle proportionality theorem, I have a example. So for the example of the triangle proportionality theorem, we have we have first A, B, and C, then D and E. So we have the given value of 12, 10, and 15. So this is 10. So first, all you have to do is find the BC. So since the BC here is unknown, so first you have to find the BC. So to solve, set up a proportion. So the 10, so you just need to copy the given values. So 10 over 15 is equal to the unknown, which is BC. Then BC over 12 is equal to, all you have to do is to cross multiply. So we have 15, then copy the unknown term, which is BC, then the answer of 10 times 12, which is equal to 120. Then 120 now divided by 15 is 8. So we have now our unknown BC, we have now this 8 for the unknown BC. So, aside from showing similarities between two triangles, we can find the length of their sides by applying the theorems and seeing the proportions. For example, give the theorem that supports the similarity of the given pairs of triangles. Then, find the length of indicated side. So we have F, G, H, and the given value of 99 and 121. So the next one we have B, C, D, and the given which is given value of 66. So, as you can see, this line is what we call triangle proportionality theorem. So, we have the solution for this given triangles. To measure or to solve the given pairs of a triangles in triangle proportionality theorem, just simply follow these steps. First, write the observable proportion. Next, solve for the unknown. Next, use the known sides. And the last one is solve for the unknown and simplify. So we can show that the triangle FGH and triangle BCD by SAS similarity theorem. So we have to first write the observable proportion. So we have the BC, which is unknown, and the BD is equal to FG over FH. Then, next is solve for unknown. So first you have to substitute the given number. So we have to copy the BC, which is the unknown, then write the given value of BD, which is 66, then the given value of FG, which is 99, then the given value of FH, which is 121. Then solve for the unknown, then use the known sides. So we have to copy the unknown, which is BC, then is equal to 99.66, which is the answer of this given value of 99.66 over 121. So 99.66 divided by 121 is 4. 54. So our unknown BC now is 54. So that's it, and I hope that you know how to solve the triangle proportionality theorem. And now, for you to be able to enhance what you've learned about our lesson for today, let's have our assignment. That ends our discussion for today. I hope that you learned something new about our discussion for today, and thanks for watching. Bye bye.